So I'm Haritha Thilakarathne, working at Tech1 as a data science and analytics engineer, doing some stuff with data and MVP in AI. Right. So humans. So when we tell a human, in our context as the coders or the geeks, the first thing that comes to our mind is a person like this, staring at like 14.1 inches wide screen for 24/7, doing the coding and handling the errors, exceptions. So those are the humans that we know, right? Agree? But humans do a lot than that. Humans smile, humans have feelings, they eat, they drink, and they smell, and they love. So, when people are moving with the computers, they thought of giving those abilities for the computers. Means they thought of like the machines also get some kind of human aspect, ability to see or ability to hear or ability to understand what the human is saying, and even the ability to smell or ability to move. So you know where the first computers came out. Can you like remember how big those computers were? Like they were like rooms, or we'll say like huge factories. But they were only able to do a simple set of tasks. But moving forward, people tend to build small machines, and the mobile that you have in your pocket is having the ability to do some kind of crazy calculations than the computer that had on Apollo 11. So we will say like this: what kind of apps that you are developing right now? What kind of apps that you develop? So we'll see. We'll say like ERP systems and POS systems. Yeah, CRUD operations, all the CRUD operations, right? And so how many mobile apps that you have on your mobile? Means like 100 plus apps. So how many apps you use daily? Obviously you are not using that. There's an app in your mobile phone called that call feature. I know that you are not using that thing, but we'll see like you are using some apps like WhatsApp and Viber or maybe Insta, apps like that. From those 100 plus apps, only some apps are like daily using. Even that phone app is not using. See, it's not using. So people tend to give that human nature for these apps to attract people. So what the human can do, not the coders, but the human can see like coders, and human can hear. I know like developers don't hear when the client's talking, but humans can smell, and then they can talk, and they can touch the things. Obviously you can touch the things. So when you started computing, I guess like he's the oldest one here, but others I think they started computing in like 10 years back. That means like 2007. Okay, 2007, right. Actually, I touched a computer back in like 2001. Yes, 2001 when I'm at grade 5, and so at that time, yes, I was at grade 5 at that time. So at that time, the computer was like pretty amazing. It had some games on it, and when it comes to programming, we actually didn't had an idea what programming was, but I tried what is that called, GW Basic. So GW Basic was basically like this. I thought all the computers are only having two colors. white and black, because there was only like, for coding we had to do like sequential programming. 10, we had to put a sequence number like 10 CLS, 10 do this thing, and for loops we had go to commands and all. So that was the time that computers came into the world with this CLI. And then GUIs was introduced. People tend to use those graphical interfaces. I don't know who invented mouse, but Steve Jobs say like he gave some motivation for the mouse. But somehow people moved into the graphical user interfaces. Then people didn't even remember these kind of apps was there. But I know the people at BOC actually know these kind of apps are there right now, because they are using this kind of app. And then, can you remember this guy? Anyone who haven't used this guy? So this came, as I remember, back in like with Office 97 or 2000. So this guy was pretty weird, and people tried to give some human aspect with this. This little Clippy had the ability to give some weird answers and give some weird helps. The only thing that this guy was able to do was giving a hyperlink to go for Microsoft help. But people thought this is the intelligence. So we had the ability to change this one to dogs and cats even. So I think this is the first ever, not first ever, this is some like pretty good move a company did to move forward with the idea of assistance and with the idea of giving some human kind of a touch for the computers. Can you remember that TV character called Virgil in Crash Zone? So in fictions, there were some good characters. So programmers, you know, like we have two ways to program a language. One is giving these kind of sequential instructions in any language that you know. It might be Java or Python, C#, anything. These kind of programs are the programs that you write right now, as I know. So nothing different, all if else and switch cases, methods, functions, those are the things that you do currently. But to give some intelligence for these apps, we need something beyond these curly braces. We need something more human-like programming thing to do these kind of things. Can you see this one? This is Eliza, built back in 1964, meant to be the first chatbot ever developed. Built back in 1964, not the year that Sri Lanka got independence. So, can you? So this one was like had the ability to chat with a person and give some like psychological counseling. This was developed in MIT. So that was having the ability to give some counseling for the people and chat with the people and give some help for them. All these instructions back on this ELISA was hard-coded. There were no AI component on that. But people tend to believe that human is typing all those messages. People tend to believe that there's some kind of a magic behind this, because people are so much attracted for the magics. And can you recognize this one? So from one of the famous films? Yes, Ex Machina. Why I put Ex Machina here was, do you know a guy called Alan Turing? So Alan Turing was a prominent figure who built some crazy stuff, who built the Enigma even, Enigma cracking algo. So he was the one who first gave some kind of a definition for artificial intelligence. He said, you know Turing test, right? That Ex Machina film is all about Turing test. Anyone who doesn't know what Turing test is? All right, Turing test. So it is like this. In Turing test, that is a test to evaluate whether that AI is good or not. What we're going to do is we're going to put, we'll say AI is a machine into room A, and we're going to put a human into the room B, and there's another human in a room C, and the person in the room C can't see room A and room B. He doesn't know who is in room A and who is in room B. What that room C person is doing is he's asking some questions from both A and B, and based on the answers and the responses that A and B will say people giving, he is going to tell in which room that human is and in which room whether the computer or the program is. If that computer can hide himself from that test, that meant to be a good AI. So that is basically the Turing test. That's the main test that we are doing right now to evaluate how good the AIs that we are building. So this giving some human touch came with the idea of cognitive computing. Have you heard the term cognitive computing? This is like giving some human touch for the computers with some computerized models. Because you know, like how the computer is working, it's working with ones and zeros. So they can't think. Those silicon chips or the sand chips, they can't think. They can't do some magic. They just work on logic. So cognitive computing is the area that which gives those computers the ability, like we'll say, it's showing us that they have the ability to see and they have the ability to think and all. In cognitive computer systems, they have the ability to do natural language processing. Anyone in any experience with NLP? Right. So what kind of stuff that you have done with NLP? Speech recognition. Right. So those are some pretty cool apps, like recognize human speech and recognize the parts of the speech, and predictive analytics, giving some predictions based on the data that we have, and adaptive algorithms. Have you heard the term of genetic algorithm? So some kind of adaptive algorithms that adapt according to the instances that we had in the past and adapt the algorithm according to that. And image recognition, I guess you all know about image recognition because some company recently released a phone with face recognition. And then reasoning and decision making apps, and emotional intelligence. Giving some kind of emotional intelligence, we'll say human, like a person, the computer will say, you look somewhat sad, you looks blushing, you looks happy. The computer says like that. That is emotional intelligence. So these are the things that cognitive computers or cognitive computing systems perform. This is not a new thing. This was like pretty old. So I know you guys back at unis and all have played with these stuff. OpenCV, grabbing all those libraries and setting a machine on OpenCV is a nightmare. And doing some image recognition tasks and edge detection, those stuff, pretty good stuff. And doing some NLP with NLTK, installing all the libraries for your machine, and that's pretty cool. So you did these things, and I'm pretty sure you anyone with neural networks experience? Anyone coded a neural network on MATLAB or Mathematica? Right. So I know, like doing some stuff on neural networks is like coding the things and all. So I'll give a basic. Anyone who doesn't know anything about neural networks? We heard. Okay, we'll do a small one, right? Great. So those things, those things that we had, all these things needed a huge computation power. Can you remember back in university when you coding your project with OpenCV, there's only one machine in your batch that can run OpenCV. Can you remember that era? So that was my experience. That was like not so far. That was back in like 2014. There's only one machine in our batch that can run OpenCV because that needed some good computation power to do the things. And to do some predictions with neural networks, so it needed like a huge power, huge RAMs and huge computation power. The machines were like heating like heaters. So we had to put fans on those machines because the machines might be exploded or something. So that was the computation power that we needed. So I would say that people try to do those cognitive things back even in 80s and 70s, but what they were lacking was the computation power and the computational paradigms that we have right now. Then the cloud era came. All are talking about cloud. People tend to use clouds, and some big companies came up with some pretty awesome clouds and plans that we can use them, pricing plans and many more things. When it comes to cognitive computing, these companies these are not the only companies who does provide cognitive computing solutions or cognitive computing APIs. Like Microsoft, Amazon, Watson in IBM, and Google and BigML are some companies who do these kind of stuff. So we'll go back to this one. All said like you are developers. What are the languages that you use for developing? So many guys are with C#. So I know you guys know C#. You guys know how to use the libraries and all, get the NuGet packages and all. So if you want to put some intelligence for your app, I would say C# is not so good on doing those things. Making a neural network or doing some natural language processing. I'm not sure whether C# is very much prominent in doing those things. Might be can do, but processing time and the libraries that you have to use is not good for this. So what you guys going to do? You guys going to use another language or learn a new language, a new paradigm and go forward? Do your clients allow that? So we'll say like this. There's a client, he need an application that can detect your face and say, okay, hello Haritha. When you see on app, like the app is telling, hello Haritha. You have a little bit of time, you don't have the time to do the research and learn a new language and do the thing. So what are you going to do? So these companies have come up with some great solutions with REST APIs that you can just put a JSON in and get the JSON out. I know you guys know a lot about JSONs. Handling JSONs with Newtonsoft, you are geniuses, I know. So, so getting back some JSON input will do all those magics that you saw in science fictions. On Google, they have solutions like Vision APIs. Have anyone used these Google services? So you have these stuff on the right side, these stuff just APIs. And if you want to go further with like machine learning development and all, they have these cloud machine learning engine. And if you want to go so further, they have TensorFlow for deep learning kind of stuff. For these stuff, no coding required. Even the business guys, you are able to do the stuff with these stuff, the right side ones. And this is an image that I put on Google Vision API. This is the image. Can you see the image? I just Google and put the image, and you can see I just uploaded the image for the API, and the API is giving back me the tags that can put for these images. Water, recreation, fun, tourism, vacation. Some are not like relevant. We'll say like fun, relevant with fishing. I don't know. Fishermen and animal source foods. All these tags are generated within like milliseconds by just calling an API. See the possibilities that you can do with this. So what you can do with this? Think of a crazy idea. So you can do many crazy things with this. And this is with the text analytics API on Google. I just put a text on this, and it's giving the tags for me. You can tag the documents with this. Think you have a big library, right? You are lazy on reading as me, but you need to know what are the keywords and what are the things that inside those books. You just do some OCR and put the text onto this kind of a API, and API will generate the tags for you. Then you can index all your books in that library or the e-library right now and give for the search. No computation for full text search, just giving the tags, and you can make a tag cloud kind of thing, some crazy things you can do. Those are the possibilities on these APIs. And then Microsoft comes into the scene. Anyone who was in that Ben's session? Right. I guess Ben talked about these things, right? So on cognitive services, they have a lot of APIs right now on computer vision, and then with speech, knowledge search, and language. Many APIs they are coming up with. So I'll show you. So all these coming up as REST APIs. I know you guys speak REST, right? So no need of worrying about the underlying architecture of those computational models, computer vision algorithms. No need of giving any kind of touch on those things, just a REST API. So with the computer vision API, can you see this, Jason? I'm not sure. So this is an image I put on Microsoft Vision. So put an image of Sigiriya, and even it is tagging the name of the one. This is not from the name of this image. The name of this image was something else. There were no meta tag on that image calling Sigiriya or something. The service itself detected the name using that famous places or landmark API. Can you imagine some kind of app that you can make with this for tourism? You know, we have Atamasthana, we have Solosmasthana. What about an app like this? Just take an image and it gives you what the place is, right? Those are some possibilities that you can do. You can make the clients wow. So this is a bit long. So this is in 3 columns. This is JSON that got from that Sigiriya image. It says it's Sigiriya with the confidence of 0.98, and it's giving some tags here like grass, water, hill, many tags here. So you can do many things with those tags. So I want some volunteers right up here. This is an app that written, this is open source. So what they have done was they have used some computer vision APIs and those APIs. So you can see in this app, they have used some vision APIs and all to create some awesome application. So in this application, this is basically that UWP app. So what the application does is it's using all the API, some APIs on cognitive services on Microsoft. It's having some crazy features. So we'll see. This is so you can see this pretty gentleman out here. So you can take a photo. Not touch. So you see whether it can detect. All right, faces detected. This is from the face API having the ability to detect the faces, and they are identifying both of them are males, and so giving an age 38. So that is those things are done only using APIs. Only some few API calls, right? And another crazy one. So you can do anything and get a photo. So in this one, what they going to do? We'll see. Okay, what they're going to do is they're going to get the faces and say what are the emotions that they have, right? It says like they are happy. I don't know why, but it's saying like they are happy. So these kind of things can be done, and I'll show another one, but it's not working so well. I have to do some. No, you have to stay right. So in this one, they are doing real-time analytics, and they are telling how the people in front of the application feels right now. Okay, it's telling 34 male for Fikri, and neutral, right? It's telling neutral. So, can you imagine some kind of a crazy application that you can build up with this one? Have you seen billboards? Have you seen billboards in any like in MC or somewhere? Right. So can you imagine a billboard adjust their advertisement according to the people in front of that billboard? If a person with a beard is there, they are showing some big racer ad or something. If there are girls there, they'll show some advertisement on, I don't know, girls like. So anything like food, ice cream, so those things. So those kind of crazy, thank you, like, you have done a great job on this. So these kind of apps can be built upon this. No neural network or any algorithm deployed on this single application. All these things have done just with API calls like this, right? So that is the power that you can get with these pretty cool APIs. And then we'll move forward with this. Right. I told you, like you told there are like 100 plus apps with you. How many apps that you are using? What is the most frequent app you're using right now? Facebook. Okay. What else? Instagram. Okay. What else? WhatsApp. Okay. Viber. And any millennials like me here? I know, like most of the people here are like in their 20s, late 40s, right? Okay, 20s. So what they do is, if you like get into a bus or train right now, you can see all the people are like this, right? All the people are like this. They just locking and unlocking their phones. Right? Some are just chatting. Right? Can you imagine a day without a single chat? Can you imagine like a world without chats? What is the last time you got a call for your crush? But what is the last time you put a message for your crush? Saying like, hello, good morning. That good morning message. Oh. Right. So people tend to use messaging apps a lot. So even like they are not calling, they just message. Even at SOS, they just put a message saying like, help me, not calling. So software companies and the developers tend to put that influence of messaging apps into applications. That means you have many apps in a phone that you are not using, right? If we'll say there's a company who can you can do flight booking called Skyscanner. Have you used that Skyscanner site? So you can book flights on that. So think that Skyscanner is having a mobile app. Do you wish to put that Skyscanner app to your phone to just book a flight? No, you just go to computer and do the thing, right? You don't want to waste your 64 GB for that Skyscanner, right? So what you're going to do is go for computer and do the thing. But think that Skyscanner capability, that app capability comes to your chat window. That's a hit, because people will love to use it. You know, like we are so much into Facebook. We use Facebook a lot. But the people who are like younger than us, like in their 21, 22 and 23, they are not using Facebook now. They just use, like recently with the surveys, they just use Snapchat, WhatsApp and Insta. Right? So they are not into Facebook even. So they tend to use chats a lot. So if you're targeting your market, if you're targeting those youngsters, you need to build some applications that come up with those chat interfaces. Not the chats, like build a web chat or some another application that you can chat, but get your application into the prevailing chat applications. That's where the bots comes. Anyone who have developed a bot development? Right. It's still on research. Okay. So there's a rising market on bots. This is I got this from Google Trends. That means how many people have searched the term chatbots, and it says like some kind of a rapid increase going on. People are so much interested on chatbots. Every company is talking like, okay, we have to develop a chatbot. We need people to develop chatbots, and we're going to market with the chatbots. The chatbot is our new strategy and all. So what the hell is this chatbots? So that is not a new thing. That is an application. There's no AI or NLP bounded with this, I would say. There's no huge magical power behind those chatbots. Have you used any chatbots? What are the chatbots that you have used? Any chatbots that you have used? Skype. Yeah, Skype you have. On Messenger you have. On WhatsApp, right now we don't have chatbots. On WeChat we have. What are the chatbots that you have used? So there are like pretty good chatbots right now, even in Sri Lanka. There's no pizza ordering bot right now in Sri Lanka. So there are some apps like Give News, like news chatbots, and what are chatbots in Sri Lanka? News apps in Sri Lanka, but in the world there are many chatbots that you can chat. Have anyone used a chatbot called Mitsuku? Oh, so that is a dating chat app. So there's there's an app on that, like a virtual character. You can just flirt with that character. So that is another part on chatbots. But apart from that, there are some good chatbots. You can do transactions even. As I said, that Skyscanner chatbot, you can book a flight with that. You just have to give the destination and the dates and all, and chatbot will do the thing. No magic behind that. What they're doing is the clicks and mouse rollovers that you have done in your web applications and desktop applications, they have moved all those things into that chat interface and giving those natural language inputs, it's rolling out the app. That's the basic thing currently going on with chatbots. When it comes to understanding natural language, they do some kind of stuff with machine learning and we'll say some kind of classification on understanding the intention or the intent of that particular natural language portion, right? That is the thing going with chatbots. If you have like any more concern on chatbots, let's have a chat after this. So there are many chatbots currently in the market, so go and see how the chatbot's going on. That is pretty easy to build a chatbot. There are many frameworks. Currently, like if you're good with C# and all, bot framework is a good place to start. With few code lines, you can build a chatbot. Just very easy to go with that. And then machine learning. So this is some kind of fun. Machine learning. Any idea on machine learning? Anyone heard the term machine learning? Right. Anyone know what machine learning is? Okay. Anyone have used machine learning? Why I asked this thing was, you know, like eBay, you guys just bought the things from eBay, right? So when you search something on eBay, have you ever noticed that something that is related to that search term is coming to your Facebook, right? If you search for something like a ticket on Google, we'll say a ticket to Goa or ticket to Thailand. Some good things will come to your Facebook, might be for your inbox too, right? So that is machine learning. As this meme said, so it's doing some recommendations based on the searches and the things that you have done.
So those are for cross-domain cookies, right?
Yes, those are good. Getting those things and building recommendations upon that, many things. So most of the cases they build recommendations. So even that you guys say this item is related to this item and all in eBay, they build recommendations on that. Some good some basic example. And on analytics, have you used that Google Street View? Not Street View, traffic thing on phone. How they track the traffic? Do they have satellites all over us?
They use our phones.
Yes, they use our phones, and they do some analytics and give these are the areas that with huge traffic and all. And have you ever built some predictive applications on your day-to-day development? No, right? So I'll show you a pretty easy way to build some applications with machine learning. So previously, this is on Quora. Like, I guess you don't like, right? So they are asking like the people who do machine learning and stuff, data mining, modeling and stuff. They call like data scientist. One is asking what kind of machine that they need to have. This one, a computer scientist, he is telling he's having 256 GB DRAM workstations and with huge RAMs and all. But to handle that kind of data, huge amount of data, that is the need. But no need of that kind of machines when you have the power of cloud. So here what I'm going to discuss about Azure machine learning a bit, not a deep dive. What Azure machine learning can do and how as programmers you can adapt for this. A quick example or quick thing about machine learning. What actually machine learning does? What do you think? Any guesses? I need some answers. What actually machine learning is doing? Predictions. Right. How they do the predictions?
Data mining.
Data mining. Oh, what kind of thing that they are doing?
So mostly frequently used stuff.
Frequently used stuff.
Find patterns.
Find the patterns. Okay. That's somewhat close. Find the patterns. In machine learning, there are like two parts. One is supervised learning and one is unsupervised learning. Supervised learning is mostly with having a training set of data, and with labels we'll say pre-defined answers for the feature that we are going to predict. And then what we're going to do is we're going to train with those data and do the prediction for the rest of the things. And on unsupervised, what we do is we're going to see the patterns only and do the predictions according to that. So machine learning is involved with some kind of maths. So can you remember this pretty interesting equation? This one? What is this? Straight line, right? So this is not the actual definition for machine learning, but I'm going to tell something very simple, and I think that will go for your mind. So we'll say like this. You have a time here on the x-axis. We'll say the number of ice creams sold for 10 days. This is day. We'll say you have 10 days here, right? And this is the number of okay, it looks like ice cream, right? Okay, so number of ice creams, you have the days here, and we'll say, people will say, okay, we have because that girl is pretty, that ice creams are selling in a rapid growth. So this is the number of ice creams per the days. What you're going to do is, you're going to predict how many ice creams would sold on the day 11, right? This is simple maths. What you're going to do is, you're going to draw a line that is not biased, not almost biased for any line on this. You're going to draw unbiased line, a regression line, and predict how many ice creams would sold on the 11th day. So this is simple linear regression, one of the simplest machine learning, or we'll say predicting algorithms you can see. So that is some kind of a basic idea about machine learning. That is predicting based on the data that we have. You can do many things on this. You can do classifications, spam ham, you know the problem, right? Classify the emails, spams or hams, and classify the documents, and classify some flowers, and image recognition. You can do many things using these algorithms. Classifications, regressions, this is just linear, non-linear classifications are also there, and you can do things here. And I'm pretty sure when you see these equations and all, you'll hate me because machine learning is not for us because it comes with maths. We don't like maths. I know, but you need to do the thing because clients need that. So what are you going to do? In Azure ML Studio, that is really simple. All the data that you have on your blobs or your SQL databases on Azure or in CSV files, and even currently for Microsoft SQL servers on Preview, right? Yeah, on Preview. You can get the data from those data sources, and you just put this into ML Studio. I'll show you ML Studio in minutes. And then on ML Studio, no need of coding. If you want to code, you can code, but here, if you don't want to code, just drag and drops, do the magic here, and deploy that thing as a web service. After that, you know the thing. REST API, Newton Soft, right? So you can do all the things with web services and embed your application on this. Think you're going to build application with some predictive abilities for the mobile, but you can't do all those huge algorithmic things on mobiles. Limited processing power, the battery will drain in minutes if you do the thing. So in here, just put it at a API endpoint and call the thing, and that will do the thing. So in Azure ML, what we do is firstly you have to have an idea what the objective is, what you're going to predict, and then you have to collect the data. Already you have the data. I know in your ERP systems, what else that you develop, like hotel reservation systems, you have the data. And then you have to prepare the data. That will take a lot of time, preparing the data and handling the missing values, hell of a job, and develop the model and train the model and analyze that thing, and then publish the model and monitor the ML model. Pretty sure you can't see this thing. So in Azure ML, almost like many machine learning algorithms, we'll say neural networks, support vector machines, logistic regression, what else? Decision forest, decision trees. Most of the algorithms are pre-built. You just have to drag and drop. So why we can use ML Studio is it reduces the complexity of doing these kind of math stuff, most of the cases, and no need of Python or R, because people in ML landscape, they use Python or R for this stuff, and no coding, top class machine learning algorithms, and the power of cloud, no need of huge machines. Your laptop will do the magic, and RESTful APIs, and easy collaboration. You can share the things with your colleagues and get some ideas. R and Python support, because it supports to get R and Python code snippets inside those modules. You can customize the things then. And VW, Warpal Wabbit, for distributed machine learning stuff with text mining and all, some complex stuff. So before moving for the demo, how much time? All right. Before moving for the demo, we'll move forward with this neural networks. Any idea? That is not a magic, not a magic on neural networks. That's some kind of mathematical equations in a proper place doing this neural network thing. So this is the equation on neural networks. I'm not going to explain a lot on this because that might be a bit boring. And deep learning, have you heard the term deep learning? Yes, because people talking on deep learning a lot. It is not a black box. It's just adding more layers and some patterns for simple neural networks. More hidden layers and more patterns like convolutional patterns or TNNs and all. So that is deep learning or deep neural networks. So I'll go for the demo with this final slides right now. So you just can go for ML Studio with studio.azureml.net, and there's a free workspace too. You just can go for an experiment and create a new experiment from here, and I'll show you that drag and drop interface when you go for new experiment. So this is the drag and drop screen that you have. So this experiment is right. Have you heard that character recognition? 1, 2, 3, 4. That handwritten character recognition. There's a famous data set called MNIST data set, recognizing the handwritten digits. So this application, this machine learning model was built to do that classification, that is a multi-class classification. I just put the data set as CSVs. You can see the CSVs. These are like matrix values. If you say these are metrics, you have the number here, handwritten number here, and if you say these are zeros, these items are having ones, you know how the image is represented as matrix, right? Right. So these are the inputs that I got from those pixels, and I have the training data set and all. Here I just want to do is, I want to do a multi-class classification. So I just search in classification. You can see some multi-class classification algorithms like multi-class neural networks are here. You just drag and drop it here and adjust the number of hidden nodes and all on here, and it will do the rest for you. Not going to discuss how the machine learning works and all. And if you have any idea about like confusion metrics, I think loaded. It's loading. So right. So right here, this is the actual value 0, 1, 2, 3 and 4 like that, and this is the predicted class. You can see in most of the cases this is giving out the output for like 98% and 97%. So that is a good accuracy for this kind of a classification, right? So anyone very good with neural networks, like have done some neural network experiments and all? So this is the basic idea, no need of coding on this, but if you pretty good in ML and all, want to go further with ML, you just can use ML Studio on this, and you can define your neural network architecture on this. This is a deep learning CNN or convolutional neural net written on net sharp, something similar to C sharp, net sharp for neural networks. So that is the idea. And small demo on the cognitive services APIs, and a thing that you can do. Another thing, as the developers, you have homework right now. You have to go home and do these things right now, right today before sleeping. So we had a problem right now these days with that wonderful ship. So that bringing oil to Sri Lanka. So so you see, like people tend to use websites a lot, and people tend to ask the question, when the ship coming, when the ship coming, right? So those have become like frequently asked questions on these days. But on companies also we have some FAQs. The reception people, you know, like how many questions that come to reception desk with the same question, right? What are you going to do? There's a simple answer. You can make a chatbot with that, right? You can just few clicks, see how many clicks I'm doing. You just go for Q&A maker.ai, and I'm going to make this as I'm going to make a chatbot for Port Authority, Sri Lanka, SLPA. I have the FAQs here, and I just copy the URL, give the URL here, and then create. Right, and it's getting all those FAQs into this service and training a model. You can see all the FAQs came here, right? And then here's the chat interface that I'm having. I can say hi. Can you see the thing? People at the back. Here. Okay, I'm going to do right. I'm selling hi, selling hello. And then I'm going to ask, like, I just like read all the FAQs that they had. I'm going to ask what is the depth of basin? That means they're asking about the basin depth. That okay, it's telling like 15 meters. It's somewhere here on this FAQ. Think how easy it is, neither using this kind of a website or going for a chat app like this and integrating this thing into a messenger app or something. And you can just publish this using a simple API. You can publish this thing. So I'm going to ask, like, when the oil ship coming. No good match in KB, right? So FAQ doesn't have that thing. And then all this AI stuff. Do you on Mark side or on Ellen side? Mark is telling no need of having regulations on AI. Ellen, you know Ellen, right? That Tesla guy. He's telling you should have some kind of proper regulations on AI. Mark side, right? We have one. Ellen's side, okay, we have many. I'm not telling in which side I am. So that's up to you. And that is Mark and Ellen. But your CEO might ask, you do all the machine learning and these AI stuff, but why not getting 100% accuracy? So show these memes for him, because you can't get 100% accuracy on these any cognitive service or machine learning or those stuff, because all these things are based on probabilities and some probabilistic algorithms. 80% would work great. Any questions?
Yeah.
Yes.
So those chatbots can be hosted on our own sites, or we need Azure.
On your own site.
If you have like a host domain somewhere else, but in Azure, can we use this?
Yes. What you have to do is you don't have to use that Azure bot service. There's a GitHub for web chat, right? You can just get that thing. It's running on npm Node.js. You just get that thing and deploy that thing on your service.
So that's not Microsoft, right?
That is not Microsoft. No. That is Microsoft. That is Microsoft web chat channel. You have to access that web chat using the direct line of the bot service. You can host not in Azure but in any place.
So if you're using Azure, we can use these other services.
Other services, bot services and all. All right. For cognitive APIs, to accessing and doing some crazy stuff with cognitive APIs, you just need to know how to access a REST API. That's enough. For ML, I would say you should have a good knowledge on machine learning theories. We'll say it will go for like theories for like 45%, and 15% with some statistics, and rest with some computer science and Python or R and how to use those things, and like 10% general knowledge, like how to use those things and all, and not to apply machine learning in each and every place. So that is a combination of theories and practices. And if you want to work with deep learning and all, you need to have an idea about multi-threaded programming and GPUs, parallel computing, because that make your programming so easy. Thank you very much.